Welcome, Thomas Tutors. Today we're going to investigate our very first video lesson. So let's go ahead and take a look at our objective. Students will be able to add monomials and polynomials using visual diagrams. Before we take a look at today's objective, let's go ahead and review what we already know. How do we add 7 plus 6? We know that when we add things together, we combine similar units. So if I were to represent the number 7 and number 6 with objects or things, I wanted to count them all together to find a sum. So if I have 7 green circles and another 6 green circles, if I add them together, 7 plus 6, if I were to count each of these individual blocks, individual circles, I'm going to get a total of 13 circles. I want to keep that in mind when I'm thinking about what does addition look like when I'm using polynomials. We want to investigate further, what does it mean when we're not just adding numbers, but when we're adding objects? For example, say what if I had 5 oranges. I represent the oranges with these words, 5 oranges. And I wanted to add those oranges to apples, 4 apples. I want to think about, are oranges and apples the same? Can I combine them together? Would I say that if I had 5 oranges and 4 apples, do I have a total of 9 oranges? Do I have a total of 9 apples? Well, we know that oranges and apples are not the same object, so we actually can't combine them together. So let's take a look at how we represent that. Say we have 5 oranges, and we're going to add together 4 apples. I've abbreviated oranges with O's and apples with A's. Or if I were to do O plus O plus O plus O plus O, and then add it together with A plus A plus A plus A. Well, the letters O and the letters A's are totally different, so when I combine them together, I need to only add together things that are the same. So my final answer is actually 5 O's plus 4 A's, because oranges and apples are not the same thing, so we can't combine them together. We want to keep that mindset when we are talking and adding together polynomials. How does this going to apply to different variables and expressions? What happens if we're looking at different letters and how are they combined if they're different units? Let's go ahead and investigate our new vocabulary so that we're familiar with what we're talking about in this lesson. Monomials is an expression that includes just one term. So in my example, I have 2x squared. I have a bunch of letters and numbers in that one single term, but still considered a monomial because there's only one expression. Whereas polynomial is an expression that has a bunch of these monomials but put together with addition or subtraction signs. For example, 4x plus 6. 6 is a monomial, and 4x is a monomial. When we put them together, we have a polynomial. Now we want to talk about what monomials look like. 4x squared, that is one monomial. What are the different parts that we have in this monomial? The number 4 that's big in front of the variable is called the coefficient. We're going to look at coefficients when we're combining these monomials together. The smaller number that's raised in superscript, is the exponent. That tells us how many times are we multiplying that variable together. And the letter, the letter X, which can also be used to represent other letters or symbols, is called the variable. Also, one thing that we need to keep note of is that exponents, when we're speaking about monomials, can also be referred to as degrees. And we use degrees to determine which terms are alike. Let's go ahead and take a look at combining these monomials and polynomials together. So here's one polynomial, 4x cubed plus 5x squared plus 6x plus 9. And I have a second polynomial, 2x cubed plus 6x squared plus 4. Now, it's considered a polynomial because we have different monomials and constants, which are the 9 and 4, combined together in an addition sentence. But what might you be thinking? These are the common errors that students make when they're trying to combine these polynomials when taking a look at just the numbers itself. So in this example, you might be thinking, well, let's go ahead and take all these numbers and add them together and get a total of 24. Because if you look at all the numbers, hey, let's add them together and write 24. And then maybe you want to keep the variable the same, and then you want to add together the exponents. 3 plus 2 plus 1 is 6. You might want to do the same thing with this polynomial, adding together the 2 plus the 6 plus the 4 to get 12, and then the exponents together to get the 5. You might be thinking that. And then moving further, what if we combine the two polynomials together? What does it look like when we're adding these? So 36 is the sum of our coefficients, keeping the variable the same, and adding our exponents. This is a common error and a common mistake when we're combining polynomials that I don't want you to do. So how do we do it correctly? How do we correct that error? Let's try again. I've rewritten the first polynomial and the second polynomial, but notice how I'm treating them as if I were to treat different digits in a whole number, like thousands, hundreds, tens, ones. But in this case, I have different x's or different variables with different degrees to represent different places. So if I take a look at my two polynomials, I notice that the second polynomial has a slight change. It has this additional 0x because I want to make sure that I'm lining up all of my like terms together. The x cubed with the x cubed, the x squared with the x squared, the x's with the x's, and numbers, coefficients without the variable are actually called constants. They're not going to be treated the same as coefficients. So let's go ahead and add them together. So when I treat these variables or these monomials, I want to think about those apples and oranges. Would I combine apples and oranges together? Similarly, would I add x cubed and x squared together? No, because they're different expressions. So I can only write things that are the same together. So how many x cubes do I have? I have 6 x cubes. How many x squareds do I have? I have 11 x squared. How many x's? I have 6 x's. And how many constants do I have? 13. You'll notice that when I add a polynomial with a polynomial, my answer is another polynomial. Just like when I add a whole number with a whole number, my answer is going to be a whole number. Let's try a different problem. Practice together. Notice how I have two polynomials. Here's my first polynomial. Here's my first polynomial. I'm combining it with my second polynomial. Now we would set up it the same way that we would the other problem that I just demonstrated. I have x to the fourth, but I don't have x to the fourth in my second polynomial, so I'm just going to write 5x to the fourth again. I don't have any x cubed in my first, so I'm going to write 0 x cubed. Then I have an x squared, then an x, and then my constant. I'm going to do the same exact thing. I notice I have 2x cubed, so I'm going to write it under the 2x cubed. I have x squared, so I'm going to line those together. I have an x, since I don't have any x to the fourth in my second polynomial, I'm going to rewrite that, and I don't have any constants. Once I have all these digits lined up, all these expressions lined up, I can then finally add them together. 5x to the fourth plus 2x cubed plus 4x squared. If you have an expression with no coefficient in front, you're going to treat that as a 1. So 1x squared plus 3x squared is going to give you 4x squared plus 10x plus 9. So that is my final answer for my polynomial. Now notice how when I added 6x plus 4x, I get 10x. This doesn't mean that we're going to carry that x into the next place. This is a separate expression. So we're going to treat it like a separate expression, and we can't combine it with terms that are not alike, just like we can't combine apples and oranges. Let's go and take a look at a problem on your own. Let's see if you can solve this problem. Practice and see if you can get the right answer.